Hi everyone, welcome to the series of lectures on causal inference from observational studies. You've already been through a series of lectures, and in this series of lectures I will be taking you through the topic selection bias. So I have divided this section into 4 subsections. So in the first subsection we will be seeing what is selection bias and an overview of it, and this will be followed by a section on selection biases in case control study, followed by a section on selection bias in cohort studies, and then in the final 4th section we will talk about how to handle selection bias in observational studies. In the first subsection, let us see how to describe selection bias and what does selection bias do to causal inference. So every epidemiologist's dream is to be able to infer causality between the exposure and the outcome under study. And every epidemiologist's nightmare is all those effects that hamper the inference of causality between an exposure and an outcome. So some of these effects which tend to hamper our causal inference process we are familiar with. One is chance variation. Just because of chance, we are either not able to detect an association between an exposure and outcome which exists in reality, or we are detecting an association or we are detecting a causality between an exposure and outcome when in truth it does not exist. But we are also aware that chance variation can be overcome by increasing your sample size. So let us assume you have that study with that perfectly large sample size to the extent that you have evaded the effect of chance variation on your inference of causality. There are still some effects which we should be aware of that hamper your causal inference, and these are the subject of discussion in this topic, which is selection bias, confounding and measurement bias. And these effects are the ones that we will be discussing in the series of lectures to follow. The first one is confounding, then selection bias, and then measurement bias. Confounding is the presence of common causes of your treatment and outcome, or it is the presence of a common factor that is associated with both your exposure and your outcome. I would like to stress on the term common causes. So there is this particular factor which precedes or which is associated with your exposure and your outcome, and because of the existence of this factor, you are wrongly deriving a causal association between your exposure and the outcome under study. So the commonly cited example which I have also picked up for explanation here is when I'm looking at the exposure, say carrying matchsticks, and the outcome, lung cancer. Now this is my exposure and this is my outcome, and I'm trying to look for causality between this exposure and outcome. Now let us say there is a third factor which is smoking. So we're all aware that somebody who smokes is more likely to be carrying matches with him or her, and somebody who is smoking is also at a higher risk for lung cancer. Now in this example, smoking is that common cause which is associated with both the treatment and the outcome in our example. So we will be falsely inferring a causality between carrying matches and lung cancer if we are not aware of and if we are not controlling for this third factor, which is smoking. The next factor that we have to discuss is selection bias. Now, selection bias happens when you are conditioning on a common effect. Now again I stress on the term common effect of the treatment and outcome under study, or a common effect of a cause of the treatment and effect that are being studied. Now let me try to explain it with an example. Now I am trying to study if there is a causal effect between a certain genetic mutation E and smoking, which is my outcome. Here I refer to it as D. So let us say there is a third factor which is coronary artery disease, and this particular genetic mutation is known to cause coronary artery disease, and coronary artery disease, like we are all aware, is also an effect of smoking. Now in my study design, if for some reason I have chosen to select people who have heart disease, so I have restricted my population to only those with heart disease. Now what happens is a person in my study population who is not a smoker is more likely to have suffered his current episode of coronary artery disease due to the genetic mutation, and vice versa. A person in my study population who does not have genetic mutation E is more likely to have suffered his current episode of coronary artery disease because of smoking. So by restricting myself only to those with coronary artery disease, I am falsely inferring an inverse relationship of causation between genetic mutation E and smoking D. So just by restricting my population to only those who have coronary disease, I have falsely inferred causality between genetic mutation and smoking, where in truth it may not exist actually. So I repeat, selection bias occurs when you are conditioning on a third factor, which is an effect of both the treatment and the outcome in the study. The third factor, the third bias that again hampers with causal inference is measurement bias, which is the subject of discussion in the next series of lectures. Let us take a closer look at selection bias in this slide. So selection bias is a systematic error that may occur because of the manner in which you have selected subjects into your study. For example, inappropriate selection of controls in a case control study. It can also occur when there is a selection in terms of who is retained in the study, or in other words, at the end of your study period, who are the people whose data you will be analyzing. Now, an example here would be informative censoring or loss to follow-up in case of cohort study. Now, what does this do? Why should we be worried about this? Because this leads to systematic differences between those who are being analyzed compared to those who were eligible to be in your study population. I repeat, so by virtue of selecting people into your study using certain criteria, you might have led to a certain bias in your study because those whose data was ultimately analyzed were systematically different from all those who were eligible to be in your study. So, in other words, bias is introduced by non-random selection of subjects from source population into the study population, and this error is introduced when the study population does not represent target population. We all agree that we do studies on samples so that we are ultimately able to extrapolate it or generalize it to a larger population, but that cannot happen if your selection suffers from certain biases. And this selection bias can be introduced at any stage of your study. It can happen at the design stage when you are deciding whom to include and whom to exclude in your study. It can also happen during the implementation phase of your study. Like we just saw, people may be lost to follow up in the due course of your study. So people who are ultimately remaining in your data to be analyzed are very different from the set of people whom you started the study with. So I think by now it is clear that both case control and cohort studies can suffer from selection biases. What then about randomized experiments? We all think that randomization is a panacea to eliminate all sorts of biases. But in truth, randomization is the perfect solution to dissipate or remove any factors that would lead to selection of people, or randomization does away with dissimilarities between the treated and the control group in your study. But I would say it is still prone to selection bias. In a later slide, we will see how so. So in this slide, I have tried to depict selection bias using, by now you are familiar with directed acyclic graphs. So using a DAG, I have tried to represent selection bias. Now, let us look at the exposure E and the disease D, and I have represented C as the factor that represents selection. So the box around C represents that I am conditioning on that factor, which means I am restricting who enters based on that particular factor. So all that requires for selection bias to happen is an arrow from E to C, which means C is an effect of E, and another arrow from D to C, which means that C is also an effect of D. And if you recollect from the previous slides, selection bias occurs when you condition on a factor that is an effect of both E and D in your study. So let us look at selection bias now with an example. So in this example, genetic mutation is the exposure and smoking is the outcome, and we are trying to see if there is a causal effect of genetic mutation on smoking. And we know that this particular genetic mutation is known to cause coronary artery disease, and so is smoking. So in this study, let us say I have conditioned on C, which is coronary artery disease, and by conditioning here I mean that I have only included people with coronary artery disease in my study. So what happens here is I am falsely going to infer a causality between E and D because I have conditioned on C. Now, just to brush up on what you've already studied on the DAGs, you can see that C is a collider here because there are arrows coming from both E and D which go into C. So by conditioning on that collider, you are going to falsely open up a pathway between E and D. Now, selection bias is referred to using so many names, and there are so many named selection biases named after a particular person or a particular instance where that type of selection bias was identified or named first. Some examples are Bergson's bias. We'll see a little more about it later. It is also referred to as healthy worker effect or self-selection bias, missing data bias, or loss to follow-up bias. It's good to remember that all of these are selection biases, and they describe bias that occurred due to selection that happened in a particular environment, in a particular study setting. So having seen that, why are we so worried about selection bias? What is it going to do to us? So if you see, a selection bias can affect the inference that you are making about causality between your exposure and outcome, because the association between the exposure and outcome among those selected in your study differs from the association that exists among all those who were eligible to be included in your study, which means the subset that you have selected for analysis is going to give you a wrong value for association between the exposure and outcome because of certain biases that crept up during selection. This will lead to incorrect calculation of causal effect. Now, doesn't that defeat the entire purpose of your research? And it occurs not only in observational studies but also in randomized experiments. So it is something that you have to be even careful of when you are doing a randomized experiment. So as a summary of this subsection, please understand that selection bias occurs when you condition on a common effect of both the treatment and the outcome. It may occur in case control studies, cohort studies, and even in randomized experiments. It hampers the process of inference of causal effect of treatment on the given outcome. Thank you.